Hi guys, good morning. How are you? I hope you're okay. So far in chemistry, well, we've been looking at moles, grams, conversions, and all that, right? And I told you that for the next topic, which is stoichiometry, this needs to be really clear. And we're also going to review the chemical equations, but because with stoichiometry, we need to make the chemical reaction, we need to balance the chemical reaction, and then figure out what's next, okay? So we're going to go back to chemical equation. What is a chemical equation? A chemical equation is a chemical reaction, and it's the process by which one or more substances that are called reactants are changed or produces one or more different substances. So for example, here you have sodium and chloride. They are adding together and they're going to produce sodium chloride, which is table salt. So we have that first example. The reactants are the ones that are starting the reaction, the starting substances. And the products are the ones that are formed by this reaction. If you recall, we have different types of reactions, and we're going to see them right now. So we're going to start with, for me, the most simple one, which is the synthesis reaction, which is the one that we had right there with sodium and chlorine, all right? So all this is in page 229. All right, page 229. Then we're going to see the balancing, because I know some of you didn't see this last year, so we're going to see the balancing, or for those of you who had trouble. So we're going to start with the types of reactions. First one, we're going to talk of synthesis. Synthesis reaction is the one in which we are adding one or more substances to form a new substance. So we are adding, you add one or more to form a new one. All right, so we add one or more substances to have a new substance. So for example here, it's the same thing we had like sodium and chloride. We already had this example. And it's going to form a sodium chloride. Why? Because this one has a charge of +1. This one has a charge of -1. This we already know it, so I'm not going to go through that. We have another example, hydrogen plus oxygen. So we're going to have H2O. All right, that's a synthesis reaction because we're producing one substance out of one or more. All right. We have a little bit more complex reactions such as calcium oxide plus silicon dioxide, which is going to produce calcium silicate. All right. This is synthesis reaction. Again, for me, is the simplest one because we just need to add and we have one new product. So synthesis reaction. This video or today's assignment is please copy the types of reactions, their definition, and the examples of each, right? Because later on we need to identify the different types of reactions. So this you need to know. If you don't understand what I write, well, on the book you have a well-defined definition of all the types of reactions. All right, so that was the synthesis. Synthesis, we create one substance out of different reactants. Number 2, we have single displacement reaction. What does single displacement mean? I'm going to change one element by another element. And in here, if we have two metals, we change those metals. If we have two nonmetals, we change those two nonmetals. So for example, we can have chlorine as a molecule plus potassium bromide. What's it going to produce? If it's telling you that if you have two metals, you're going to exchange the metals. And if you have two nonmetals, you're going to exchange those nonmetals. So in this case, chlorine is a nonmetal and bromine is a nonmetal. So this means I'm going to switch them. All right? So in the single displacement reaction, I'm going to have potassium chloride plus bromine as a molecule. All right, are we clear? Why bromine as a molecule? Because remember, it's a halogen, and halogens are always placed as molecules. All right, that's rules. I think we saw it this year, and if we didn't, well, we saw it last year. But if you don't know that, halogens are placed as molecules. All right, and let's make an example with a metal. We have aluminum plus, aluminum is a metalloid, remember that, plus iron, iron 2, oxygen 3. We have aluminum plus iron oxide. In this case, we have a metal and we have another metal. So in this case, I'm just going to switch my metals. All right. So aluminum is going to move here, plus iron is left alone. All right, so this is a single displacement reaction. It's really simple because we just need to change one metal by the other metal, or one nonmetal by the other nonmetal. All right, let's move on to the third chemical reaction, which is double displacement. Double displacement reaction. What does this mean? Double displacement. I'm going to change 2. Let's have, here we have an example. We have lead with chlorine. Lithium sulfate. Why is it called double displacement? Because I'm going to change my nonmetals, and that is going to create 2 different substances. So in this case, I have here my nonmetal, and I have all this as a nonmetal. Why? Because this is a polyatomic ion, and I'm going to move it as a polyatomic ion. So these 2 change places, and we're going to have 2 different products. So that's why it's called the double displacement reaction. One moves here, and the other one moves there. It's two movements that you need to make. So we're going to produce lead sulfate plus lithium chloride. All right, double displacement. We just switched them. All right, let's make another example. We have zinc bromide all right, we have zinc bromide and silver nitrate. Again, we have here our nonmetals, and we have here our polyatomic ion. So I'm going to change this, exchange places of this 2. So zinc is gonna bond with nitrate. So we're gonna have zinc nitrate plus silver bromide. All right, if you're wondering